Good morning. This morning we're going to be talking about building the unit circle. My name is Melody Elrod, and you can find me online at www.melodyelrod.com. I'm a private tutor who is based in Tennessee, but I tutor online as well. So if you find this helpful and you'd like to talk to me about helping you out on a regular basis, just feel free to drop by my website and send me a word. So building a unit circle. A few notes about building the unit circle. First of all, a lot of you have probably been in classes where your teacher has required you to memorize the unit circle. And if you're like me and memorizing the unit circle is not something that you do very well, or memorizing anything for that matter, my math facts were just sad when I was a little girl. I used to always stall when I had to do flashcards. I hated those because memorization didn't make any sense to me. Just trying to put two pieces of information together and link them arbitrarily just never really set well in my brain. And if you're like me and you don't memorize well, then it may be helpful for you to see how to build the unit circle. Now, if you're one of those people who memorizes things really well, then you may find this unnecessary and you may not find it very helpful. But if you do need some help other than just memorization, this may be the way for you to go. In order to build the unit circle, uh, it's helpful to look at a couple of right triangles first, because these right triangles are going to be really essential in understanding what we're going to put into the unit circle later on. It also helps us to have kind of a starting place on what angles we're really focusing on. So the two triangles are the 45-45-90 triangle and the 30-60-90 triangle. You've probably seen these before. You can find proofs of their side-to-side ratios online or in textbooks, and I leave it to you to prove them to yourself. But the ratios of the sides are 1, 1, rad 2 for the 45-45-90 triangle, which actually you can see with the Pythagorean theorem, and 1, 2, rad 3 for the 30-60-90 triangle. And again, memorizing not my forte. So I remember this one more easily if I can remember that 2 is the longest of those three sides and therefore must be the hypotenuse. 1 is the smallest of those three sides and so therefore must be across from the smallest angle, a 30-degree angle. And rad 3, being between 1 and 2, must be across from the 60-degree angle. We're going to use more of that information in just a moment. What we're going to do right now is kind of put it to the side, let it rest for a moment, and go directly to our unit circle and begin doing a little bit of labeling. In the unit circle, let's just give ourselves a little bit of vocabulary here in the quadrant names. Quadrants 1, 2, 3, and 4. The quadrants are labeled in counterclockwise fashion because that's the way that angles move through the unit circle. They move counterclockwise, where 0 starts right here. And before I go any further, I'm going to recommend that you pause your video and either take a screenshot and print it, or go get a big bowl or something like that and draw yourself a big circle. Give yourself plenty of room. Don't make this a small circle. You're going to have a hard time putting all of the information into it that needs to go into it if it is a small circle. So take a moment, pause your video, make sure that you have a circle to use. Okay, now you've done that, I'm sure. So let's keep going. We could, in the grand scheme of a whole circle, a circle is 360 degrees, label every single degree, 1, 2, 3, 4, all the way up to 360. But that would be really tedious. It would be very visually confusing, and it would just be a pain. So what mathematicians tend to focus on in the unit circle are the reference angles that we just named. The 30-degree angle, 45-degree angle, 60-degree angle, and 90-degree angle. Because, of course, we know that anything that lies within a triangle has to be acute. Those are all going to be right here in this first quadrant, between 0 and 90 degrees. We also know a little bit more about the circle without trying too hard, and that is that a full rotation is 360 degrees, right? So to go all the way around is 360 degrees. We know that to go halfway around is 180 degrees. And if I added 180 plus another quarter, this 90 degrees, we've got 270 degrees down here. So that gives us a little bit of information to get started with. Now, how to label the other angles. The other angles are essentially just the same thing in the second, third, and fourth quadrants as they are in the first quadrant. But what we have to use to label those is what we call reference angles. Reference angles are those angles that are measured from the x-axis to the angle in question. For example, if I wanted to measure, and I'm going to use a different pen for just a moment here. If I wanted to measure from here all the way to, say, here, well, I can figure out how far that is by measuring with a protractor or with any other means. I know it's less than 180 degrees and it's more than 90 degrees, but I could also simply measure the reference angle. Okay, the reference angle is the same as it is over here. This is a 30-degree angle, and so therefore this must be a 30-degree angle, which means if I take that 180 degrees and I subtract off the 30-degree angle, well then sitting right here on this line, I have 150 degrees. So let me take my purple back off, pick my orange back up, and put in my 150 degrees. Now the same thing is true for this angle. If I subtract off 45 degrees from 180 degrees, I get 135 degrees. If I subtract 60 degrees, I'm at 120 degrees. Now you'll notice that I'm putting degrees on absolutely every one of these, which feels redundant, but I promise you is necessary. So let's just keep up with the correct notation. In mathematics, it is often tempting to let our notation get lazy, but I warn you against doing so. It can be a very serious danger, because once you start mixing a lot of different kinds of notation, if you're not clear about your notation, then some of your answers become very fuzzy. It's very difficult to tell what's being combined with what is used in what kind of units, all those kinds of things. So let's stay nice and firm with our notation. On into the third quadrant, I do the same thing. I take my 180 degrees, I add my 30-degree reference angle, and I get 210 degrees. I add 45 degrees, and I get 225 degrees. I add 60 degrees, and I get 240 degrees. In my fourth quadrant, from 360 degrees, I subtract 30 and get to 330. I subtract 45 and arrive at 315, and I subtract 60 and arrive at 300. So there's all of our degrees all the way around the circle. It's not the prettiest picture we've ever had, but it works. Now hopefully you've done a little bit of explorations into radians as well, but let's start to talk about radians. And by the way, at any point during this video, it is a video, so hopefully you already know this, but I just want to remind you that if you need to stop, make notes, make it a little bit more explicit than what I've already talked about. If you want to draw in something that I've erased, if you want another unit circle to make extra notes on, take a moment, pause your video, do what you got to do, and then come back to it. So radians. Radians are a measure kind of like circumference. Radians measure what portion of the arc measure I've gotten to. So as I move around the outside of this circle, I have to remember that circumference, how do I measure circumference? Circumference is measured in 2 pi times the radius, right? Circumference is 2 times pi times the radius. Well, since we're in the unit circle, the circumference is 2 times pi times 1, or just 2 pi. So the circumference of this full circle is 2 pi. Which means that if I go all the way around, 2 pi is going to coincide with 360 degrees, meaning that half of the way around, pi will coincide with 180 degrees. And these are called radians. So 2 pi radians is a full circle. Pi radians is half of a circle. That means that half of pi would be a quarter rotation, and 1.5, right? 1.5, or 3/2 pi, is 3/4 rotation. Now, I tell my classes on a regular basis that if you get friendly with fractions, radians will become your friends. It will become so much easier to see the way that radians work in a unit circle if you feel comfortable with fractions. For example, 30 degrees is 30 out of 180. Okay, it's on the way to pi, it's only 30 out of the 180. It is 1/6 of the way to pi. 45 degrees is half of a half. It's a quarter of pi. 60 degrees is 60 out of 180. It is 1/3 of the way to pi. And we can continue this trend. Okay, you probably learned, let's pull circumference back up for just a minute here. You probably learned when you were converting degrees to radians that if you want to get your radians, if you take your degrees and divide by 180 degrees and multiply by pi, you've got it. And that's what I'm doing here. Okay, I'm doing so in a less obvious way, in a less stated way, but in a way hopefully that will let you see what's going on here. I also like to look at the portions of the circle. So 1/3, this is 2/3. If 60 degrees is 1/3, then twice that, 120, is going to be 2/3 of pi. Now notice that I'm writing them as a fraction of pi. I could also write it as 2 pi over 3. That's the very same thing. So 135 degrees, well, I've got a quarter, a half, and 3/4 of pi. In fact, I'll write this one as 3 pi over 4. It doesn't matter. They're both exactly the same thing. 150 degrees, we've got a sixth, a third, a half, 2/3, and 5/6. You can think of this just like we figured out the reference angle. Pi, 1 whole pi, minus a sixth is only 5/6. It's just slightly less than 1. Okay, we move on around. 1 and 1/6, the nice thing about the bottom half of the unit circle is that it's just 1 and a little bit more, 1 and a little bit more. And so it's a mixed number that we can actually change into a fraction. So we've got 1 and 1/6 is 7/6. 1 and 1/4 is 5/4. 1 and 1/3, 4/3. 1 and 1/2, we already said, is 3/2. 1 and 2/3. 1 and 3/4, 7/4. 1 and 5/6 is 11/6. And so now we have these portions of the triangle all nice and tidy. It's all taken care of. So we now have degrees and radians for all of our reference angles in the unit circle. Done. Okay. I would suggest that you practice that a little bit. If any of that was confusing to you, make sure that it makes sense in your mind. Take a few notes before you go on if you need to. All right. Let's talk a little bit about these points around the unit circle. I want to start with these points right here that I'm highlighting at the quadrant angles, because these points are actually on the x-axis and the y-axis. It's really easy when we're building the unit circle to forget that we're actually just sitting on the coordinate plane. That's it. We're just sitting on an x-y axis. And so every point that's on the circumference of the circle has coordinates. It has an x-coordinate and a y-coordinate, and those are going to help us in just a moment to do some trigonometry kinds of things. But for right now, we can figure out what they are actually quite easily without thinking about trig at all. So the coordinates of this point right here, because we're on the unit circle, meaning it has a radius of 1, is that we will move from the origin to the right 1 and then not move off of the x-axis. So the y value will be 0. So we'll have the point 1, 0. Up here at pi over 2, our quadrant angles rest at 0, 1, right? 0 x-coordinate, 1 y-coordinate. Back here, we're at -1, 0. And at the bottom, 0, -1. So those 4 are pretty easy. But what I want to begin to tackle are these points in here. And this is where our triangles are actually going to come in quite handy. So what I want to do, and you're going to notice that I flip back and forth between several different circles for the remainder of this video. If you want to take a moment and draw yourself some extra circles, you're welcome to do that. It's not absolutely necessary, but you might find it helpful. Pardon me. Okay, so let's look at So I've got a clean unit circle here, because if I draw all of this information inside the unit circle that's on the previous page, well, it's going to get real messy real fast. So I want to give myself a chance to understand the concept without clouding things. If I build a triangle right here inside the unit circle, I'll shade this in. I don't know if it'll, oh, it will shade it, good. And I call this, so I know that this angle right here is 30 degrees. If I build a right triangle by dropping a point or dropping a line straight from this point to the x-axis, I have a 30, 60, 90 triangle. Beautiful little 30, 60, 90 triangle. And as we talked about back here on this page, we know that the 30, 60, 90 triangle has a ratio of sides 1, 2, rad 3. Well, let's see if that works in the unit circle. If I put a ratio of sides 1, 2, rad 3 on this triangle, it almost works. And the reason that I say it almost works is, what did we just say the radius of this circle is? The radius of this circle is not 2, it's 1. So this, if I drew it this way, would be hanging way out of the unit circle. It's not doing what I want it to do. So what I want to do is to make this 1. I want the hypotenuse of this circle, pardon me, I've got some new software and it's a little touchy. Okay. I want the hypotenuse of this circle to be 1. So I need to cut it in half. And if I cut one of the sides in half, I must cut them all in half, because that's how proportionate triangles work. Similar triangles, I just shrink down all the sides and it's still the same triangle, just smaller. So what that means is, if I cut all the sides in half, what I've just done to travel from here to this point out here is I have moved to the right, rad 3 over 2, and up 1/2, making the coordinates of this point rad 3 over 2, 1/2. Now, those are not attractive. Those are not nice, clean numbers like 1 and 0 like we had for the other ones, but they're absolutely accurate. This is what's known in trigonometry as an exact answer. There will be times when your teacher is going to ask you for the exact values of something. And it's going to be important that you understand that when you use that rad 3 over 2, that is an exact value. If I plugged it in my calculator and got the decimal answer out, that's no longer exact. So let's put this information on the unit circle. So we have this point right here, rad 3 over 2, 1/2. Okay, now let's go after the next piece. Let's go after this piece right here. Oops. Let's build another triangle by dropping a line from our 45-degree angle. That means that this angle right here is 45 degrees, which makes this angle also 45 degrees with our 90-degree angle down here. I need to shade that in as well. I think that was helpful to see it shaded. Okay, so here's our triangle. Now we know that the ratio of sides for a 45, 45, 90 triangle is 1, 1, rad 2. But again, the hypotenuse of this can't be rad 2 because it's got to fit inside the unit circle, which means the radius, the hypotenuse, has to be 1. So if we divide it by rad 2, we'll get 1. Now, dividing by rad 2 is stickier than dividing by 2, isn't it? Because we have what I like to fondly refer to as the stupidest rule in math, and that is that you can't divide by a radical. Now, once you get beyond calculus, by the way, that is no longer true, and nobody cares about that anymore. But since you're probably still in pre-calculus or possibly even advanced algebra and trig, let's go ahead and rationalize this denominator. Also, you know, if you take the SAT or the ACT, they're going to rationalize the denominator there too. So we multiply top and bottom by the square root of 2, because the square root of 2 times the square root of 2 is just 2. And the top becomes rad 2. So you end up with rad 2 over 2 for both your legs. So that means that we have moved to the right, rad 2 over 2, and up, rad 2 over 2. And that gives us the coordinates of this point, right here. So let's go back to our unit circle and let's put that on there. So the coordinates of this point are rad 2 over 2, rad 2 over 2. There he is. All right. So one more time, let's go up and visit this point right here and drop a line down. Now you're going to notice, hopefully, that this one is very similar to one we've already done. That this triangle is no harder than the triangle that we did first. That this is a 60-degree angle, meaning that this is a 30-degree angle, and we have a ratio of sides 1, 2, rad 3. The placement of my 1 and my rad 3 are different, though, because the orientation of my triangle is different. But again, I just cut them all in half in order to fit it inside the unit circle. So instead of rad 3 over 2, 1/2, the coordinates of this point are 1/2 rad 3 over 2. You'll notice that I'm also a stickler for putting parentheses around my coordinate pair, and that's really important. I know that it seems really petty, all these little notation things, but in mathematics, we are nothing without our notation, so I encourage you to be very exact about your notation. So let's go back and revisit the unit circle. Let's put that back on our chart here. So we've got 1/2 rad 3 over 2. And believe it or not, you have all the information that you need now to build the entire unit circle. Because the only thing that's different about this point and the point that we just drew, this 1/2 rad 3 over 2, is that to reach 1/2 rad 3 over 2, we had to travel forward and up. But to reach this point, we have to travel back and up, meaning that the only thing that changes is the sign of our x-coordinate. So that we have the point negative 1/2 rad 3 over 2. Well, can you guess what the coordinates of this point would be? Instead of moving forward rad 2 over 2 and up rad 2 over 2, we're moving backwards rad 2 over 2 and up rad 2 over 2. So we have a negative x-coordinate again. Okay, and likewise, negative rad 3 over 2, 1/2. Okay, third quadrant, very similar. Now, instead of moving forward and up, we're going to move back and down. So instead of getting positive rad 3 over 2, positive 1/2, we're at negative rad 3 over 2, negative 1/2. We're at negative rad 2 over 2, negative rad 2 over 2. Okay, we are at negative 1/2, negative rad 3 over 2. What do you think might happen in the fourth quadrant? Well, something very similar. Instead of moving forward and up, we're now moving forward and down. So we'll have a positive x-coordinate and a negative y-coordinate. A positive x-coordinate and a negative y-coordinate. And last one, positive x-coordinate, negative y-coordinate. All right, and that is the entire unit circle. And visually, it's quite overwhelming. But if you remember, way back when, we started with this. We started with a clean slate, and we ourselves put in every single one of those pieces of information until we filled in the entire unit circle. So for those of you who look at the finished product and think, oh my goodness, I can't fill all that in, don't worry, you can. All you have to do is go step by step. Now, I know this is kind of a long video. 25 minutes is a long time. But I encourage you that if you need to do so, view portions of it again. Go back and practice it for yourself. Because if you put in the time now, if you really understand how to build a unit circle now, at the beginning of your unit, what's hopefully at the beginning of your unit, for some of you this may be the night before the test, then hopefully as time progresses, this will become easier to use. And I also caution you, take this seriously. If you are one of those students who's going to have to take pre-calculus, who's going to have to take calculus, who might even have to take Calc 2 and Calc 3, the unit circle is going to come in so handy. If it is stuck in your brain, if you know the unit circle, if it's inscribed in your very, gray matter, then it's going to be easier for you to do so many things in the coming math classes. So I hope this has been helpful to you. And again, if you would like to talk with me further about some of these things, please feel free to drop me a line. You can find me at melodyelrod.com. I am easily found on the web, and I hope you have a great day.